Okay, y'all. So today we're going to start discussing lesson 3-2, solving inequalities on page 38. Our learning targets for this lesson are we are going to write inequalities to represent real-world situations. How can you use an inequality in a real-world situation? Then we're going to solve multi-step inequalities. Lesson 3-1 introduced you to one-step inequalities and writing one-step inequalities. And now we're going to move to multi-step inequalities. Okay, so Chloe and Charlie are taking a road trip to the pet store to buy some things for their new puppy. They know that they need a bag of food that costs $7, and they also want to buy some new toys for the puppy. They find a bargain barrel containing toys that cost $2 each. So we know that Charlie and Chloe, they got a new puppy. They need food for the puppy that costs $7, and they're wanting to see how many toys can they purchase for their puppy when the toys cost $2 each. Part A. Part A asks us to write an expression for the amount of money that they will spend if the number of toys they buy is T. So we're going to write an expression. Expressions do not contain equal signs. An expression contains constants and variables, okay, with operation signs if necessary. So write an expression for the amount of money that they will spend if the number of toys they buy is T. So we know that they're going to spend $7 on food. A bag of food costs $7. So our cost is going to have definitely $7 in it, right? So $7 is the bag of food. Then we're going to add the cost that we spend on toys. So we're going to add the cost that we spend on toys. And our toys are $2 each. $2. Whoop, that's a dollar sign. Holy moly. Okay, let's fix that. All right, so we know that our toys cost $2. There we go. That's better. $2 each. Well, $2 times how many toys they are purchasing. Well, how many toys are they purchasing? We don't know yet. That's what we're trying to figure out. But we know that the number of toys they buy is T. The number of toys they buy is T. So it's $2 times T. So the total cost that they spend, I'm trying to write T there. Okay. The total cost they spend is $7 plus $2 times T. Part B. Chloe has $30 and Charlie has 1/3 of this amount with him. Use this information and the expression that you wrote in part A to write an inequality. So we're going to have an inequality symbol for finding the number of toys that they can buy. So now Charlie and Chloe, they know that they're going to spend $7 plus $2 times T. And they have a total of, Chloe has 30 and Charlie has 1/3 of 30. And we're wanting to write an inequality, find the number of toys that they can buy. So our inequality is going to be our cost, $7. That's a dollar sign, y'all. I'm sorry. $7 plus $2 times T. $2 times T. And we're going to skip the inequality for right now. We're going to have an inequality symbol right here at the end, an inequality symbol. Now, how much money do they have? We know Chloe has $30. So that's easy. $30. $30. Y'all, I'm sorry. My stylus pen is acting up right now. $30. I'm going to use my fingertips, see if that works better. Okay. $30 for Chloe. Charlie has 1/3 of that amount plus 1/3 of 30. Okay. Wow, that's the best I can do. I'm so sorry, y'all. Okay, so on the left side, we have $7 plus $2 times T with our block where our inequality symbol is going to go, with our expression on the right being $30 plus 1/3 of $30, which is how much they have to spend. Now, the question is, what inequality symbol do we use? We know that we have 4 different inequality signs. We have less than, we have greater than, we have less than, equal, and we have greater than, equal. Okay, so this left side inequality or expression, this left side represents their spending, okay, their cost. The right side over here is what they have available to spend. So you know that your spending cannot be more than what you have to spend. You have to spend, or you have to purchase items that are what you have available to spend or less. So your cost has to be less than your available. So we're going to have a less than symbol there. Now, in addition to less than, we're going to have equal. Our spending is less than or equal to our available funds to purchase items with. Okay, so that is our inequality. There are different methods for solving the inequality that you wrote in the previous question. Chloe suggests that they guess and check to find the number of new toys that they could buy. Use Chloe's suggestion to find the number of new puppy toys that Chloe and Charlie can buy with their combined money. So Chloe says, let's just guess how many toys we can buy. Let's say let's just substitute in 1 for T into the inequality and do 7 plus 2 times 1 and see if that's less than or equal to that amount. And then if it's less than, let's substitute in 2. And if that's less than, let's substitute in 3 until we get a value that is greater than 30 plus 1/3 of 30. So I want you to pause the video and see if you can figure that out. Okay, so by now you should have probably spent a great amount of time figuring that out. Hopefully not too much, and you eventually just gave up and found out how hard it is by using that method. That is a very hard method and not the method that I would suggest using every time. Okay, so for this example, if you did start at 1 toy and worked your way up, you would have found that when you substituted in 16 for the number of toys, you would get the value. Okay, so if you substituted in 16, if you had T equals 16, I think my fingertip works better than my stylus pen that I have here. That's a 6, y'all. Okay, if you have T equals 16, and you substituted in 16 into our inequality, you would have 7 plus 2 times 16 is less than or equal to 30 plus 1/3 times 30. Okay, and when you simplify this, you end up getting 39 is less than or equal to 40. Well, that's a true statement. What happens when you substitute in 17? I'm going to come over here to the left over here and do this. T equals 17. What happens when I substitute in 17? 7 plus 2 times 17 is less than or equal to the 30 plus 1/3 times 30 we know is 40. What happens when you substitute in 17? Well, when you substitute in 17, you end up getting 41 is less than or equal to 40. So I know if I purchase 16 toys, I would spend $39 of the 40 that I have available. If I purchase 17, that would put me over the 40 threshold, and I cannot spend $41 when I only have 40. So that would be a false statement, which means that I can only purchase 16 toys to be below my $40 available money to spend. Now, let's see if there's an easier way of doing that. Charlie remembered that they could use algebra to solve inequalities. He imagined that the inequality symbol was an equal sign. Then he used equation solving steps to solve the inequality. Use Charlie's method to solve the inequality that you wrote in item 1B. So I want you to pause the video here and see if you can follow the algebraic method of solving this inequality on your own. Okay, so by now, you should have been able to solve the inequality, and I'm going to rewrite the inequality. I have 7 plus 2 times 16 is less than or equal to 30 plus 1/3 of 30. Oh, I just rewrote the same one where I substituted in 16, y'all. I'm so sorry. That is 2t. 2t. All right, 2t. Now we're solving for the variable t. So let's just focus on the right side over there. 30 plus 1/3 of 30. Well, we can simplify 30 plus 1/3 of 30, and that gives us 40. So let's just rewrite 7 plus 2t is less than or equal to 40, because 1/3 of 30 is 10, and 30 plus 10 is 40. Now, imagine, like it says up here, imagine that the inequality symbol was an equal sign, and then use the same steps to solve the inequality. So if this inequality symbol, less than or equal to, was an equal sign, and you're trying to isolate the variable t, you follow those same steps. Okay, you need to distribute and combine like terms if necessary. We have no value that we need to distribute, and we have no like terms that we need to combine. The next step is isolate the term with the variable. In order to isolate the term with the variable, which is 2t in this inequality, we're going to subtract 7 from both sides. When we subtract 7 from both sides, 2t, the term with the variable, remains on the left side of the equal sign, and we get that 2t is less than or equal to 33. Okay, so now we need to isolate the term. In order to isolate the term, the inverse operation of multiplication is division, so we're going to divide both sides by 2. And we get that t is less than or equal to 33 divided by 2, and 33 divided by 2 is 16.5. Or 16 1/2 if you left it as a fraction. So I know that t is less than or equal to 16.5. Well, when we are talking about in terms of the toys, I'm looking ahead to make sure I don't answer another question. No. Okay, so when we're talking about in terms of the toys, can you buy 16.5 toys? No. So you would not round this up. In mathematics, typically you round 16.5 up to 17, but what happens when you round to 17? You won't have enough money to purchase all of the toys and the food. So in this case, you would round down. You would round down to 16 toys. And the reason being is that if you rounded up to 17, you would not have enough money. That's where you spent the $41 when they only have $40 to spend. Did you get the same answer using Charlie's method as you did using Chloe's method and explain? Well, it depends on what numbers you substituted in. So these answers could vary, but the answer to this should be no, because nobody, I say nobody, there could be somebody out there, but nobody in the classroom, I highly doubt, substituted in 16.5 in Chloe's method. Everybody that substituted in values and did a guess and check typically always chose whole numbers because you're talking about toys. Whereas in Charlie's method, when you use Charlie's method, you use decimals. So everyone's answer here should be no, that you did not get the same answer, because Charlie's answer contained a decimal. Decimals were not used in Chloe's method. My stylus pen decided to work finally. Okay. Now I want you to pause the video and I want you to do numbers 5 and 6. 5 and 6, check your understanding. Chloe liked the fact that Charlie's method for solving inequalities did not involve guess and check. So she asked him to show her the method for the inequality negative 2x minus 4 is greater than 8. So Chloe realized that, hey, instead of wasting my time guessing and checking all of these values, your method gives you the answer immediately. So Charlie showed Chloe the method below to solve negative 2x minus 4 is greater than 8. And if you follow these steps, Charlie added 4 to both sides to isolate the variable with the term with the variable negative 2x. And then he divided out negative 2 to isolate the variable x. And he got x is greater than negative 6. When Chloe went back to check the solution by substituting a value for x back into the original inequality, she found that something was wrong. So confirm or disprove Chloe's conclusion by substituting values for x into the original inequality. So what happens? When you follow the steps for solving an equation, he followed the correct steps. But when you substitute in the value of x into the original equation, you get a false statement. Why is that? So let's pick a number. We're going to pick a number that is greater than negative 6. My go-to, Miss DeWitt's go-to for any value that is greater than negative 6 is always going to be 0. Because if you can substitute in 0 for a variable, it makes your life easier. Okay, so Miss DeWitt's going to use 0. X equals 0. Because 0 is greater than negative 6. Well, what happens? Negative 2 times 0 minus 4 is greater than 8. Now, you can use any value that's greater than negative 6. You can use negative 5, negative 4, negative 3, negative 2. You can use positive values, 1, 2, 3, 4, 5, to infinity, because this is any value that is greater than negative 6. But again, the easy go-to is just to use 0. Now, when I simplify this, negative 2 times 0 is 0, which leaves me with negative 4 on the left. Negative 4 is greater than 8. Whoa, Chloe is right. Chloe did find something that was wrong because negative 4 is not greater than 8. So that is a false statement. So x is greater than negative 6 is not the correct solution. So let's figure out where Charlie went wrong. Charlie followed all the correct steps of solving that inequality by following the same steps that you do for solving an equation, but his solution's not right. So let's see what Chloe did. Chloe tried the problem again, but used a different step. So Chloe added 2x to both sides. She moved the term with the variable to the right side, and then she subtracted 8 from the right side to move the negative, or to move the 8 to the left side. And then she solved all the other steps. If you follow her steps right here, she got that negative 6 is greater than x. Chloe concluded that x is less than negative 6. So is x less than negative 6? So let's see if her answer is correct. Is Chloe's conclusion correct, and explain? Okay, so let's see what Chloe did. Let's do a guess and check. What is a value that is less than negative 6? A value that is less than negative 6 would be negative 7, negative 8, negative 9, negative 10, so on and so forth. So I'm going to use x is equal to negative 10. I'm going to use 10s because 10s are easy. Let's substitute it into the original equation. Negative 2x minus 4 is greater than 8. So negative 2, x is being substituted for negative 10, minus 4 is greater than 8. Negative 2 times negative 10 is positive 20, minus 4 is greater than 8. 20 minus 4 is 16. 16 is greater than 8. Well, that's true. 16 is greater than 8. 16 is greater than 8. So is Chloe's conclusion correct? Yes. She is correct. Explain what Chloe did to solve the inequality. So I didn't want to discuss that too much up here. So what did Chloe do to solve her inequality? What Chloe did that was different than what Charlie did is, instead of isolating the term with a variable by adding 4 to both sides, she added 2x to both sides to change her term with her variable to a positive number. So she added 2x to both sides. Okay, so she added 2x to both sides. And when she did that, everything became positive. Okay, but then, well, I say everything became positive. The term with the variable became positive. But then she subtracted 8 because she had to move the 8 to isolate the term with a variable. She subtracted 8 from both sides. And she got negative 12 is greater than 2x. Then she's divided out 2 to get x is less than negative 6. Negative 6, when you see an inequality, I want to point this out. When you see an inequality where your variable is on the right side, you need to make sure that you do not read this as x is greater than negative 6. Although this is the greater than sign, you've got to read this in terms of the variable. So if you see an inequality where your variable is on the right side, the best thing for you to do is rewrite that inequality with your variable on the left, and you would be x is less than negative 6. Okay, these two mean the same thing. It's just make sure that you don't make a common mistake by thinking that this reads x is greater than. X is not greater than. X is less than. Okay. So explain what Chloe did to solve the inequality. She added 2x, subtracted 8, and then divided by 2. Charlie looked back at his work. He said that he could easily fix his work by simply switching the inequality sign. What do you think about Charlie's plan? Can you just switch the inequality sign? Because if you go back to Charlie's work was all correct. He added 4 to both sides. He added 4 to both sides here. He divided by negative 2 here, which was correct. And he says he can simply just fix his work by saying x is less than negative 6. Just flip the inequality sign, and it would make it true. So what do you think about Charlie's plan? Well, his plan would be correct. If he did flip his inequality sign, then that would make this statement true because x is less than negative 6. So it would make Charlie's answer correct. His plan would correct the problem. His plan would correct the problem If he just flipped the inequality symbol, it would correct the problem. Although all these methods worked, Charlie and Chloe wanted to know why they were working. Here's an experiment to discover what went wrong with Charlie's first method. Look at what happens when you multiply or divide by a negative number. So this is going to explain to you why Charlie's idea is true. Okay, so pick 2 different numbers. So the book picks 2 and 4. The inequality 2 is less than 4. Multiply both numbers by 3. When you multiply both numbers by 3, 2 times 3 and 4 times 3, you get 6 is less than 12. Well, 6 is less than 12, so that's true. Okay, 6 is less than 12. Multiply both numbers by negative 3. Well, when I have 2 times negative 3 and 4 times negative 3, that becomes negative 6 and negative 12. Negative 6 is greater than negative 12. Okay, negative 6 is greater than negative 12. Is negative 6 greater than negative 12? Yes. Negative 6 is greater than negative 12. Divide both numbers by 2. When I divide both numbers by 2, I get 1 is less than 2. Well, that's correct. 1 is less than 2. Now, when I divide by negative 2, I get 2 divided by negative 2. A positive divided by a negative is a negative, and a positive divided by a negative is a negative. So I get negative 1 is greater than negative 2. Well, that's true. So what do you see different between multiplying by a positive number and multiplying by a negative number here? What happens in our inequality symbol? They flipped. So when you multiply by a negative number, you flip the inequality symbol. And then the same thing for dividing. What happens when we divide by a negative number? We flip the inequality. If you leave the inequality alone when you multiply or divide by a negative number, you're going to get a false statement. So when you multiply by when you multiply or divide by a negative number, you flip the inequality symbol. Okay. Number 11 says, try this experiment again with two different numbers and record your results in the My Sections note of this page. Compare your results to the rest of your class. We're going to skip that because we cannot compare results, but I do want you to try that experiment on your own. Question number 12. What happens each time you multiply each side of an inequality by a negative number? And what happens each time you divide each side of an inequality by a negative number? So what happens when you multiply or divide by a negative number? Anytime you multiply or divide by a negative number, the inequality sign flips. So you need to know that the inequality sign flips. The inequality sign flips. Whoa, the inequality sign flips. Okay, anytime you multiply or divide by a negative number, the inequality sign flips. How does this affect how you solve an inequality? Well, the solutions would flip and extend in the opposite direction. The solutions would be in the opposite direction. Now we have an example. Example A. Solve first. You have to solve. Solve and graph negative 5x plus 8 is less than or equal to negative 2x plus 23. So when you go through all the steps of solving that inequality, as you can see here, if you want to pause the video and follow them step by step, you're welcome to. But you get that the solution is greater than or equal to negative 5. Now remember, in this problem, you are going to divide by a negative number, which means your inequality sign is going to flip from, oh, that's a typo, isn't it? Let me pause this and look at it for a second. Okay, I almost messed up, y'all. Okay, so the original inequality symbol was less than or equal to, and at this step here, they went ahead and divided by negative 3 and flipped the inequality sign from less than equal to greater than or equal to. Okay, so remember, your inequality symbol in this problem, because you're dividing by a negative number in that final step, your inequality symbol is going to flip from the original less than equal to greater than equal to. So as you can remember from lesson 3-1, we know that inequality signs that have greater than equal to or less than equal to have closed points. So then we're going to have a closed point at negative 5. And our ray is going to extend in the right direction because our values are greater than, which goes in the right direction. Now, one trick that I tell my kids is when you see a variable, let me try to get that off, with greater than or equal to, your arrow is pointing to the right, which means your arrow on your line is going to be pointing to the right. Okay? All right. Math tip, substitute some sample answers back into the original inequality to check your work. Just as I stated for equations, you can substitute in values that are, in this case, greater than -5. Again, my go-to for that one would be 0. When you substitute in 0 into the equation, into the inequality, do you get a true statement? Okay, try these A. Solve and graph each inequality. So try these A. I want you to pause the video and I want you to attempt A, B, and C before you come back on and get the answer. Okay, so part A, we've got 3 minus 4x is less than or equal to, let's try that again. Is less than or equal to 11. So following the same steps that I do for solving an equation, I'm going to isolate the term with the variable by subtracting 3 from both sides. When I subtract 3 from both sides, I get -4x is less than or equal to 8. Then I'm going to divide by -4 on both sides because I'm isolating the term. What happens when you divide by a negative number? You flip the inequality symbol. So my answer is going to end up being x is not less than or greater, or less than or equal. It's greater than or equal to -2. X is greater than or equal to -2. Now the way I'll graph that on a number line, I'm going to change my color here to black to draw my number line. I'm going to have a number line with -2 in the middle. -1, 0, 1, -3, -4, -5. That's a -5 there. Okay, so my answer was x is greater than or equal to -2. Because my inequality sign is greater than or equal to, I'm going to have a closed circle at -2. It includes the value 2, and my ray is going to extend in the right direction. Okay, now my next inequality is 6 minus 3 times x plus 2 is greater than 15. So I'm going to, you can pause the video to write these notes because I'm about to erase that so that I can write the next inequality. Okay, our next inequality here is part B. 6, I'm going to try to save room so I don't have to erase this time. All right, so we've got 6 minus 3 times x plus 2, that's an x, is greater than 15. Okay. Y'all bear with me. My internet is starting to lag a little bit. Okay, so following the same steps that we do for solving inequalities, or solving equations, same steps that we follow for solving equations, we have to look first, is there anything that we can distribute or like terms that we need to combine? In this case, we do. We need to distribute -3 into x and -3 into +2. So when we distribute -3, we get 6 minus 3x minus 6 is greater than 15. Now we have like terms that we need to combine. 6 and -6 is a like term. So 6 minus 6 gives you 0. So that leaves you with -3x is greater than 15. Now we need to isolate the variable by dividing by -3. Remember, when you divide by a negative number, you flip your inequality symbol. So now we've got x is less than -5. X is less than -5. So I'm going to have a number line here. And I'm going to have values at -5, -4, -3, -6, -7, -8. Okay. I'm going to have an open circle at -5 because my inequality symbol is less than, not equal to. And my ray is going to extend in the left direction because those are the values that are less than -5. Okay, now I'm going to see if there's enough room over there for me to do part C without erasing. 2 times x plus 5 is less than 8 times x minus 3. Now I need to distribute on both the left side and the right side. I need to distribute 2 into x plus 5 and 8 into x minus 3. When I distribute 2 into x plus 5, that gives me 2x plus 10. When I distribute 8 into x minus 3, that gives me 8x minus 24. Now, I do not have any like terms that I need to combine. However, I follow the rest of the steps. I need to isolate, or I need to gather first. I need to gather my terms with my variable to one side. Now, I teach my kids to move the smaller number. In this case, the smaller number would be the 2x. So I'm going to subtract 2x from both sides. That leaves me with 10 on the left is less than 6x minus 24. Now I need to isolate the term with the variable by adding 24. And as you can see here, because I moved the smaller numbers, everything ends up becoming positive, which is what our goal is. We want to try to, if possible, keep our values positive. So I get 34 is less than 6x. 34 is less than 6x. Now I'm going to divide both sides by 6. When I divide both sides by 6, I'm running out of space here, but I have enough space. I get 5.6. 5.6 is less than x. Now remember, like I said above, you want to make sure you read that in terms of the variable. In terms of the variable, that is x is greater than 5.6. Or x is greater than 5.6. X is greater than 5.6. I have enough room to write my number line down here. So I'm going to have a number line. And I'm going to label it 3, 4, 5, 6, 7. At 5.6, I'm going to have an open circle at 5.6, which is approximately right here in between 5 and 6. I'm going to have an open circle, not a closed circle, open circle, open point, and I'm going to extend in the right direction because are larger or greater. Okay, now I want you to pause the video and I want you to attempt 14 and 15. Check your understanding on your own and don't forget to submit those in your assignments for activity 3. And then lesson 3-2 practice at the bottom of page 42 is your homework.